In question 1, the equation of a curve is such that dy dx is 3 upon x to the power 4 plus 32x cubed. It is given that the curve passes through the point 1 upon 2 and 4. We have to find the equation of the curve. To find the equation of the curve, we'll integrate the expression for dy dx. In the first step, we'll write it as dy is equals to, we'll bring the x in the numerator. So this will be x to the power minus 4 plus 32x cubed dx. Now integrating both the sides, so we'll write add the integral sign with both of the to both the sides. Integrating dy will get a y. So minus 4 plus 1 will become a minus 3, and we'll divide by minus 3 plus 32 x to the power. This will become a power 4. Dividing this by power 4 and we'll add a plus c. So minus 3 and 3 will cancel. So this will become minus 1 x to the power minus 3 plus 8 x to the power 4 plus c. We can write the equation as minus 1 upon x cube plus 8x to the power 4 plus c. Now to find the value of c, we'll substitute the point 1 upon 2 and 4. So in place of y, we'll put 4 is equals to minus 1 upon 2 whole cube plus 8 into 1 upon 2 to the power 4 plus c. So this will become 4 is equals to minus 1 upon 8 plus 8 into 1 upon 16 plus c. 1 divided by 1 upon 8 will become a minus 8. So we'll write it as 4 equals to minus 8 plus 1 upon 2 plus c. Taking it on the other side, this will become 12 minus 1 upon 2 is equals to c. So c will be 24 minus 1, which is 23 upon 2 equals to c. Finally, we can write our equation as y equals to negative 1 upon x cube plus 8x to the power 4 plus 23 upon 2. In question 2, the sum of the first 20 terms of an arithmetic progression is 405 and the sum of the first 40 terms is 1410. We have to find the 60th term. So to find the n60th term, we'll be using the formula for the nth term, which is a plus n minus 1 into d. So we need to find the values of a and d. Now the formula for sum of n terms is equals to n upon 2 into 2a plus n minus 1 into d. As the sum of the first 20 terms is 405, we can write this equation as 405 is equals to 20 upon 2 bracket 2a plus n minus 1. So that will become 20 minus 1 into d. So 20 divided by 2 is 10. We'll write this as 405 equals to 10 into 2a plus 19d. 10 will divide with 405. So we'll get an equation 2a plus 19d is equals to 40.5. Now the sum of the first 40 terms is 1410. So we'll use the same formula again for the 40 terms, which is 1410. So this will become 1410 is equals to 40 upon 2 into 2a plus 40 minus 1 into d. Simplifying, we'll get 1410 is equals to 20 into 2a plus 19d. And then 1410 divided by 20 is 70.5 is equals to 2a plus 19d. Now we have two equations. We can solve them simultaneously. So to solve them simultaneously, we can use the elimination method. 2a plus 19d equals to 40.5 and 2a plus 19d is equals to 70.5. Multiplying the second equation by minus 1, so the signs will change. This will become a minus, this will become a minus, and this will also become a minus. 2a minus 2a will cancel out. And so in this case, this was 40 minus 1, which should have been a 39d. So this was 2a plus 39d. So 19 minus 39 will become minus 20d, and 40.5 minus 70.5 will become minus 30. So d will be 30 divided by 20, which is 1.5. Now to find the value of a, we'll substitute this value of d into any one of the two equations. So using the first equation, we'll write 2a plus 19 into 1.5 is equals to 40.5. So 40.5 minus 19.5 times 2 times 1.5 will be is equals to 11.25, and then 11.25 divided by, so 19 into 1.5 is equal to 28.5. So 2a plus 28.5 is equals to 40.5. So 2a will be is equals to 12 and a will be equals to 6. Once we have the value of a and d, we can use the nth term formula a plus n minus 1 into d. So for the 60th term, we will write it as 6 plus n minus 1. So this will become 60 minus 1 into 1.5. This will become 6 plus 59 into 1.5. So the 60th term, when you substitute this in the calculator, that will be equals to 94.5. In question 3a, we have to find the first three terms in the expansion of 3 minus 2x to the power 5 in ascending powers of x. So the expansion formula for a plus b to the power n is equals to a power n plus nc1 a power n minus 1 b power 1 plus nc2 a power n minus 2 b power 2, and so on. As we just need the first three terms, so these will be the first three terms. So the expression is 3 minus 2x to the power 5. So you write it as 3 to the power 5 plus 5c1 a to the power, so a is 3 to the power 5 minus 1 into b, which is minus 2x to the power 1 plus 5c2. A is again 3, so this will be 3 into 5 power minus 2 into b, which is minus 2x to the power 2. 3 to the power 5 will be, so that will become 243 plus 5c1 is 5 into 3 to the power 4 into minus 2x plus 5c2 is 10 into the, so 3 power 3 will become 27, and this will become a 4x squared. Simplifying this, we'll get 243 plus 5 times, so this will become 5 into 81 into minus 2. So this plus minus will become a minus, so we'll get minus 810x. So 5 into 81 into 2 will become 810. Plus 27 into 10 is 270 into 4 will become a plus 1080x squared. Now in part B, we have to find the coefficient of x squared in the expansion of 4 plus x squared multiplied by 3 minus 2x to the power 5. So we already have the expansion for this. First, we'll expand 4 plus x squared till the first three terms, and then we'll multiply these to get the coefficient of x squared. So expanding 4 plus x to the power 2, this will become 4 to the power, so this will become 4 square will become 16 plus 2 times 4 is 8. So this will become 8x plus x squared. So 16 plus 8x plus x squared, and the expansion for 3 minus 2x to the power 5 was 243 minus 810x plus 1080x squared. Now to get the coefficient of x squared, we'll see which terms when we multiply will give us an x squared. So 16 will multiply by 1080, 8x will multiply by 810, and 243 will multiply by x squared, and all these terms will give us a term in x squared. So 1080 multiplied by 16 is 117,280 x squared. 8x into 810 is, so 8 times 810 is equals to 6480 x squared, and 243 multiplied by x squared will be 243 x squared. So this will become 243 x squared. So we'll finally write our answer as 17280 minus 6480 plus 243. Final answer will be 11,043 x squared. As we just have to find the coefficient of x squared, so we will just write a final answer as 11,043 for the coefficient of x squared. In question 4, the diagram shows part of the graph y equals to a tan of x minus b plus c. Given that b is 0 between 0 and pi, we have to find the value of the constant a, b, and c. So looking at the equation, this b basically represents how much the tan graph has been translated in the x direction. Now, normally tan has an infinite value at 1 upon 2 pi. So at 1 upon 2 pi, it is infinite, and the graph normally goes up like this. Now we can see that instead of 1 upon 2 pi, it is going up to infinity at 3 upon 4 pi. So if we find the difference of 3 upon 4 pi and 1 upon 2 pi, so finding the difference of 3 upon 4 pi minus 1 upon 2 pi, taking the LCM, this will become 3 pi minus 2 pi upon 4. So we can say that the graph has moved forward towards the right by pi upon 4 radians. So the value of b will be is equals to pi upon 4. To find the values of a and c, we can substitute any of these values into the equation. So let's say at x1 upon 4 pi, the value of y is 1. So we can rearrange the equation to write it as y equals to 1 when, well, this is a into tan, x is pi upon 4. The value of b is now pi upon 4 as well, plus c. So tan pi upon 4 minus pi upon 4 is 0, and tan 0 is 0. So 0 plus c will be equals to 1, and c will be equals to 1. Once we have the value of c, now we can say, now to find the value of a, we can again use the expression with a different value. So we'll write it as y is equals to a tan of x minus pi upon 4 plus 1. Now at x1 upon 2 pi, the value is 3. So we'll write it as y equals to 3 when x is pi upon 2. Simplifying this, so pi upon 2 minus pi upon 4 is pi upon 4, and tan of pi upon 4 is 1. So this will become 3 is equals to a plus 1. So a will be is equals to 3 minus 1, which is equals to 2. In question 5, the fifth, sixth, and seventh terms of a geometric progression are 8k minus 12 and 2k. Given that k is negative, we have to find the sum to infinity of the progression. So the formula for sum to infinity is a upon 1 minus r. Now to find the sum to infinity, we need the values of a and r. For r, we know that if we divide two consecutive terms, so let's say if I divide the sixth and the fifth term, or the seventh and the sixth term, the value will be equal. So I can write this as minus 12 upon 8k. The sixth term divided by fifth term will be equals to the seventh term divided by the sixth term. Cross multiplying, we'll get 8k into 2k, which is 16k squared, is equals to minus 12 into minus 12, which is 144. So k squared will be equals to 144 upon 16, which is 9. K will be equals to the square root of 9. Now as k is negative, so we'll take the value of k as minus 3. Now once we have the value of k as minus 3, we can say that the fifth term will be is equals to, which is 8k. So 8 into minus 3, which will be equals to minus 24. The sixth term is given as minus 12. So the common ratio will be equals to minus 12 upon minus 24, which is equals to positive 1 upon 2. Now to find the first term, we can use the fifth term and use the nth term formula. So the nth term is a r to the power n minus 1. Now the fifth term is minus 24 is equals to a, which is unknown, into 1 upon 2 to the power 5 minus 1. So this will become minus 24 is equals to a into 1 upon 2 to the power 4, which is 16. 24 times 16 is minus 384. So the value of a will be minus 384. Now we have the values of r and a. We can apply it now to the formula for sum to infinity. So we'll write it as sum to infinity equals to minus 384 divided by 1 minus r. So this will become 1 minus 1 upon 2. 384 divided by 1 as 1 minus 1 upon 2 is 1 upon 2. So this will be 384 divided by 0.5, which will be equals to minus 768, which will be the sum to infinity of the progression. In question 6, the equation of a curve is y equals to 2k minus 3x squared minus kx minus k minus 2, where k is a constant. The line y equals to 3x minus 4 is a tangent to the curve. We have to find the value of k. Now, in a quadratic equation, if there's an unknown constant like k, we will use a discriminant b squared minus 4ac to find the value of k. So as it is a tangent, b squared minus 4ac will be equals to 0. So first solving the equation simultaneously, the line y is equals to 3x minus 4. So in the equation of the curve, we'll replace y with 3x minus 4. So this equation is 2k minus 3x squared minus kx minus k minus 2. Bringing the 3x minus 4 on the other side, this will become 2k minus 3x squared minus kx. So we'll write the 3x will become a minus 3x and this will become a plus 4. So this will be minus k minus 2 plus 4 equals to 0. Now simplifying this, we'll write it as 2k minus 3x squared. We can take the plus x as common. So this will become minus k minus 3. And then you can open up the bracket and write it as minus k plus 2 plus 4 equals to 0. So this will become minus k plus 6. So the value of a will be equals to 2k minus 3. B will be equals to minus k minus 3. And C will be is equals to, so this will become plus 2 plus 4 is a plus 6. And C will be is equals to 6 minus k or k minus 6. Now applying it to the formula b squared minus 4ac equals to 0, we will get, so b is minus k minus 3, so we will get minus k minus 3 whole squared minus 4 into a, which is 2k minus 3 multiplied by c, which is 6 minus k equals to 0. Expanding this, we'll get k squared plus 6k plus 9 minus, so 4 times 2 is 8. So first we can multiply the brackets. This will become 12k minus 2k squared minus 18 plus 3k equals to 0. Simplifying the bracket, we'll get 12k plus 3k, which is 15k. So this will become 15k minus 2k squared minus 18. And this will be k squared plus 6k plus 9. Multiplying this by the bracket by 4, this will become k squared plus 6k plus 9 minus 60k plus 8k squared, and minus 4 times minus 18 is a plus 72 equals to 0. So 8k squared plus k squared is a 9k squared, 6k minus 60k is minus 54k, and 9 plus 72 will become a plus 81 equals to 0. We can divide the whole equation by 9 to make it simpler. So we can write it as k squared minus 6k plus 9 equals to 0. Factorizing this will become k minus 3 into k minus 3 equals to 0. So the value of k will be equals to, so k minus 3 is equals to 0. K will be equals to positive 3. In question 7a, we have to prove the identity 1 minus 2 sine squared upon 1 minus sine squared as 1 minus tan squared. Now in this identity, we can see that we have to get rid of the denominator and convert it to a form so that converts to tan squared, which means we'll be needing to convert sine squared upon cos squared to a tan squared. Now the identity is sine squared plus cos squared equals to 1. And we can also write cos squared is equals to 1 minus sine squared. In the numerator, in place of 1, we can write sine squared plus cos squared minus 2 sine squared. And the denominator, we can replace the 1 minus sine squared with cos squared. So sine minus 2 sine will become minus sine squared. So the numerator will be cos squared minus sine squared upon cos squared. Breaking up the denominator and writing it individually with the numerators. So this will become cos squared upon cos squared minus sine squared upon cos squared. So cos squared and cos squared will become 1, and sine squared upon cos squared is tan. So this will become 1 minus tan squared theta. In part B, we have to solve the equation of 1 minus 2 sine squared upon 1 minus sine squared equals to 2 tan power 4. Now we prove the identity that 1 minus sine upon 1 minus 2 sine squared upon 1 minus sine squared is 1 minus tan squared. So we can write 1 minus tan squared over here is equals to 2 tan to the power 4. So rearranging this will become 2 tan 4 plus tan squared minus 1 equals to 0. To simplify this, we can write this equation as, let's say we can use a substitution, x equals to tan squared. So x squared will be equals to tan to the power 4. Simplifying this, we'll get 2x squared plus x minus 1 equals to 0. Factorizing this will become 2x squared plus 2x minus x minus 1 equals to 0. Taking 2x common, this will become x plus 1. Taking 1 common, this will also become x plus 1 equals to 0. Simplifying, this will be 2x minus 1 and x plus 1 equals to 0. So x will be equals to 1 upon 2 and x will be equals to negative 1. Now the substitution was x is equals to tan squared. So when we use x is equals to tan squared theta, so tan theta will be equals to the square root of x. Now as we cannot take a square root of a negative number, so which means that this value will not be taken. Now taking tan theta is equals to square root of 1 upon 2. So theta will be equals to tan inverse of square root of 1 upon 2. So writing it as tan inverse of square root of 1 upon 2. In the calculator, we'll get the basic angle as 35.3 degrees. Now we know that tan is positive in the first and the third quadrants. So we'll make the 4 quadrants. We know that tan is positive in the first quadrant and tan is positive in the third quadrant. So the first value of tan will be 35.3. However, we have to look at the range, which is 0 to 180. Now, so this will be beyond the range, so we will not be taking this angle. However, the square root shows that we can also take the values of tan in the negative quadrants. So we'll also make 35.3 in the negative quadrant, as square root means we both positive and negative values are considered. So the second value will be 180 minus 35.3. So one value of theta will be 35.3 and the second value will be 180 minus 35.3. So the final answer will be 35.3 degrees and 144.7 degrees. In question 8, a diagram shows a symmetrical metal plate. The plate is made by removing 2 identical pieces from a circular disc. The boundary of the plate consists of 2 arcs PS and QR of the original circle and 2 semicircles with PQ and RS. The radius of the circle with center C is 4 and PQ is equals to RS is equals to 4 centimeters. We have to show that angle PCS is 2 upon 3 pi. Now to show this, so let's say this is the angle PCS. We know that the radius is 4, so this and this length is also 4. They were given that the length PQ is 4 and this length CQ will also be equals to 4. Now, as all 3 of these lengths are equal, it means that all the angles are equal. So each angle will be pi upon 3, and this will also be a pi upon 3. As this is a straight line, so we can now say that this will be equals to pi minus pi upon 3, which is equals to 2 pi upon 3, which shows that angle PCS is equals to 2 pi upon 3. In part B, we have to find the exact perimeter of the plate. So the perimeter of the plate consists of 4 arcs. So the perimeter of the plate is consisting of the arc PS and QR, which are equal in length. So this is arc of PS plus QR and the lengths of SR, which are basically semicircles. So this is the arc of SR plus the other semicircle arc, which is PQ. Now to find the length of the semicircle of the circumference PQ, so we'll use the circumference formula. So we know that the circumference of a circle is equals to 2 pi r. Now as it is a semicircle, so we'll divide by 2. So we'll get 2 pi into the radius now, as this total length is 4. So the radius will be 2. So 2 pi into 2 upon 2. So this will become a 2 pi. But as there are two lengths, so this will become a 2 pi multiplied by 2. So the total length for the two circumference of semicircles will be 2 pi multiplied by 2, which is equals to 4 pi. And to find the arc length of PS, so finding the arc length, we'll use a formula S equals to R theta. So S is the arc length, R is 4, and theta is 2 upon 3 pi. So this will become 8 upon 3 pi, and we'll multiply this by 2, as there are two arcs, QR and PS. So this will become 16 pi upon 3. So the final answer for the perimeter will be is equals to 16 pi upon 3 plus 4 pi. You can take the LCM and simplify to make it 16 pi plus 12 pi upon 3. So the final answer will be 28 pi upon 3. In part C, it is asking us to show that the area of the plate is 20 upon 3 pi plus 8 root 3 centimeters squared. So now if you look at the figure, we can divide this figure into two sectors and two triangles. So we have two sectors PCSQCR and two triangles PCQ and CSR. So we'll find the area of all these four parts and then finally subtract the area of these two semicircles to get the area of the plate. And the first step, we'll find the area of the sector. So area of a sector is given by half r squared theta. So that will become half into r, which is 4 squared, into theta, which will be 2 pi upon 3. Simplifying this will become 16 pi upon 3. Now, as there are two sectors, so we can multiply this answer by 2. So this will become 32 pi upon 3 for the area of the two sectors. For the area of triangle, we'll use half AB sine C. So area of a triangle is given by half AB sine of C. So the two lengths are half into 4 into 4. And the angle was pi upon 3, as this was an equilateral triangle. So this will become 1 upon 2 into 4 into 4 into sine of pi by 3. Substituting this in the calculator, so this will be 16. Sine pi by 3 is root 3 upon 2. So this will be 16 into root 3 upon 2 multiplied by half. So this will become 4 root 3. So area of one triangle is 4 root 3. So area of two triangles will be 2 times 4 root 3, which will be equals to 8 root 3. Now finding the area of the semicircle, which will subtract from the total area. So the area of semicircle will be pi r squared upon 2. And then we'll multiply this by 2 as well, as there are two semicircles. So the radius was 2 for the semicircle. So this will become 2 squared into pi upon 2 multiplied by 2. So 2 squared is 4. 4 divided by 2 is 2. And then again multiplying it by 2, this will become a 4 pi. Now to find the area of the plate, we'll add the area of sector and triangle. So for the area of plate, we'll add the area of the sector, which was 32 pi upon 3, plus the area of the triangle, two triangles, which was 8 root 3, and subtract 4 pi. So we have to give our answer in the form 20 upon 3 pi plus 8 root 3. We already have 8 root 3 over here, so we'll subtract the terms in pi. So 32 pi upon 3 minus 4 pi plus 8 root 3. Taking the LCM, so this will multiply by 3 and this will multiply by 3. 32 pi minus 12 pi will become 20 pi upon 3, and we'll leave 8 root 3 as it is. So this will be the area that we had to prove for the area of the plate. In question 9, the function f and g are defined as f of x is x minus 2 whole squared minus 4 and g of x is ax plus 2. In part A, we have to state the range of f. Now from the function f of x, we can see that the turning points have their coordinates 2, comma minus 4, and x is greater than equals to minus 2. To understand this, we can represent this on a graph. The turning point is at 2 and minus 4. And as x is greater than equals to 2, the graph will be going upwards. So the range of f of x will be equals to greater than or equals to -4. In part B, we have to find f inverse of x. So to find f inverse, first we'll write y in place of f of x. And this is x minus 2 whole squared minus 4. Exchanging the values of x and y, this will become x is equals to y minus 2 whole squared minus 4. Taking 4 on the left hand side, we can write this as x minus y minus 2 whole squared equals to x plus 4. Now taking the square root, this will become y minus 2 is equals to the square root of x plus 4. And then taking minus 2 on the other side, this will become x plus 4 plus 2. So we can finally write our answer for f inverse of x as square root of x plus 4 plus 2. In part C, it says that given that a equals to minus 5 upon 3, solve the equation f of x equals to g of x. Now, f of x had the expression x minus 2 whole squared minus 4, and g of x was equals to ax plus 2. So as a is minus 5 upon 3, this will become minus 5 upon 3x plus 2. Taking 4 on this side, we'll get x minus 2 whole squared is equals to minus 5 upon 3x, and plus 2 plus 4 will become a plus 6. Now expanding the left hand side, we'll get x squared minus 4x plus 4 is equals to, taking the LCM on the right hand side, we'll get minus 5x plus 6 upon 3. Now cross multiplying, we'll get, and this was x minus 2 whole squared minus 4. So this, there will also be, so this will become, okay, so we are already taking the 4 on the other side. So this will become x squared minus 4x plus 4 is equals to minus 5x. And we have taken the L, so minus 5x plus 18 upon 3. Cross multiplying, we'll get 3x squared minus 12x plus 12 is equals to minus 5x plus 18. Simplifying the equation, we'll get 3x squared minus 12x. So minus 5 will come here and become a plus 5x plus 12 minus 18 equals to 0. So the final quadratic equation will be 3x squared minus 7x, and 12 minus 18 is a minus 6 equals to 0. Using middle term breaking, we'll get 3x squared minus 9x plus 2x minus 6 equals to 0. So now taking 3x common, this will be x minus 3 plus 2 common, x minus 3 equals to 0. So the two values of x we'll get is 3x plus 2 into x minus 3 equals to 0. So x will be equals to 3 and x will be equals to minus 2 upon 3. Now, as x has to be greater than 2 upon 3, so we'll ignore this value for minus 2 upon 3 and only take the value x equals to 3 as our final answer, as f of x cannot take values less than or equals to 2. In part D, it says that given instead that gf inverse of 12 equals to 62, we have to find the possible values of a. Now, the function g of x was is equals to ax plus 2. And the function f inverse of x we found in the previous part was square root of x plus 4 plus 2. Now to find gf inverse, first we'll find the function gf inverse of x, which means that in the function g, in place of x, we'll replace the function f inverse. So in place of x, we'll write square root of x plus 4 plus 2, and the plus 2 will be outside the bracket. So multiplying it by a, we'll get a square root of x plus 4 plus 2a plus 2 for the expression for gf inverse. Finally, to get gf inverse of x, it means in the function g, we'll substitute the function gf inverse. So the function g of x was ax plus 2. Now in place of x, we'll substitute this whole function, which is a into square root of x plus 4 plus 2a plus 2, and the plus 2 for g of x will be outside the bracket. Now when x is 12, the value is 62. So we can write it as 62 is equals to a bracket of a into square root of 12 plus 4, 16, plus 2a plus 2, and the plus 2 will remain outside. So 62 will be is equals to, so square root of 16 is 4. So a into a is a squared. So this will become 4a squared. A into 2a is 2a squared. plus 2a plus 2. Simplifying this, we'll get 6a squared plus 2a plus 2, and we'll bring the 62 on this side and put it equals to 0. So the equation is 6a squared plus 2a minus 60 equals to 0. Solving this equation, we can write this as dividing this equation by 2. This will become 3a squared plus a minus 30 equals to 0. Now we can substitute these values in the calculator to get the value of a, or we can do midterm breaking. So as we have to get 3 into minus 3 minus 90 and plus a, we will use plus 10a and minus 9a for our midterm breaking. Now taking a common over here, this will become 3a plus 10. From over here, we'll take 1 common. So from here, we can take 3 common. So this will become 3a plus 10. So this will become a minus 3 into 3a plus 10 equals to 0. So the two values of a will be equals to a equals to 3 and a equals to minus 10 upon 3. As it asks us to find the possible values of a, so both of the values will be needed for the final answer. In question 10, the equation of a circle is x squared plus y squared minus 4x plus 6y minus 77. In part A, we have to find the x-coordinate of the points A and B where the circle intersects the x-axis. Now, when a curve or a line intersects the x-axis, the y-coordinate is 0. So let's say the point A will have coordinates x1, 0, and the point B will have coordinates x2, 0. Now, substituting y equals to 0 to the equation, we'll get x squared minus 4x, as y squared will become a 0, and this will become minus 77 equals to 0, as 6y will also become a 0. Factorizing this, we'll get x minus 11 and x plus 7 equals to 0. So the two values of x will be x equals to 11 and x equals to minus 7. So we can say that the point A will have coordinates 11, 0, and point B will have coordinates minus 7, 0. In part B, we have to find the points of intersection to the circle at A and B. So let's say if we have a circle and we have 2 points A and B, let's say this is the point A and this is the point B. So we have to find the point where the tangents intersect. So let's call this point as point D. Now to find this point of intersection, point D, we first need the equation of the tangent at A and the equation of the tangent at B. Now to find the equation of the tangent, we already have the coordinates of B. We now need the gradient. So to find the gradient, if we are able to find the center point from the equation, this will be perpendicular to the tangent, and then using negative reciprocal, we'll be able to find the gradient of the tangents. So the equation that we had was x squared plus y squared. So this is x squared plus y squared minus 4x plus 6y minus 77 equals to 0. Now, if we have an equation of a circle, this minus 4 is equals to minus 2a from the general equation of a circle, which means that a will be equals to minus 4 upon minus 2, which is 2. This is the x coordinate of the center, and this plus 6 is equals to minus 2b. So b equals to minus 3, and this is the y coordinate of the center. So the center has coordinates 2, minus 3. Now in the first step, finding the gradient of AC, that will be, so we have coordinates of A as 11, 0, and coordinates of B as minus 7, 0. First, finding the gradient of AC, that will be minus 3 minus 0, y2 minus y1 upon 2 minus 11, which will become minus 3 upon minus 9, which is equals to positive 1 upon 3. And now finding the gradient of BC. So the gradient of BC will be 0 minus 3 y2 minus y1 divided by minus 7 minus 2. So this will become plus 3 upon minus 9, which is equals to minus 1 upon 3. Now, once we have the gradient of BC and AC, which is equals to 1 upon 3 and negative 1 upon 3, the gradient of the tangent, so the gradient of the tangent at AC will be equals to the negative reciprocal, which is minus 3, and the gradient of the tangent at BC will be equals to positive 3. Once we have these two gradients, now we can find the equation at AC and at BC. So the point A was 11, 0. Using the equation of a line y minus y1, so y1 is 0 is equals to minus 3 into x minus 11. And then finding the gradient, finding the equation at point B. So y coordinate is 0. The gradient is positive 3 into x minus. So the y coordinate was minus 7. So this will be minus 7. So for the first equation will be y equals to minus 3x plus 33. And the second equation will be y equals to, so this will be 3 into x plus 7, which is equals to y is equals to 3x plus 21. Now we have both the equations of the tangents. To find their point of intersection, we'll solve them simultaneously. So we'll write it as y is equals to minus 3x plus 33. And this is y is equals to 3x plus 21. Minus 3x and 3x will cancel. This will become 2y is equals to 33 plus 21, which is 54. So the y coordinate will be 54 upon 2, which is 27. Once we have the y coordinate, we can now find the x coordinate using any one of these two equations. So using the first equation, we'll get 27 is equals to minus 3x plus 33. Bringing the 3x on this side, this will become 33 minus 27, or 3x will be equals to 6. So the x coordinate will be equals to 2. So the point of intersection for the two tangents will be 2, 27. In question 11, the equation of a curve is y equals to 2 into square root of 3x plus 4 minus x. We have to find the equation of the normal to the curve at the point 4, 4, giving our answer in the form y equals to mx plus c. Now to find the equation of the normal at the point 4, 4, we need the gradient of the normal. So to find the gradient of the normal, we'll first find the gradient of the tangent. To do that, first we'll find the dy dx of the curve. So first we can write this as y equals to 2 into 3x plus 4 to the power 1 upon 2 minus x. Now finding the dy dx, which will give us the gradient to the tangent. So dy dx will be equals to half into 2, which will become 1. So this will become 2 into half into 3x plus 4 to the power minus 1 upon 2. And we also multiplied by the derivative of 3x plus 4, which is equals to 3. So this will multiply by 3 minus 1. So 2 and 2 will cancel, and we can finally write dy dx will be equals to 3 upon square root of 3x plus 4 minus 1. Now to find the dy dx, we'll substitute x equals to 4. So dy dx will now become 3 divided by 3 into 4, 12. So that will be equals to 16 minus 1, or 3 upon 4 minus 1. So 3 upon 4 minus 1 will be equals to negative 1 upon 4. Now this negative 1 upon 4 represents the gradient of the tangent. So the gradient of the normal will be is equals to the negative reciprocal, which is positive 4. Finally, we can write the equation as y minus y1. So our y1 was 4 is equals to 4 into x minus x1. So that was also 4. We can simplify this equation to write it as 4x minus 16 plus 4. So the final answer will be y equals to 4x minus 12 for the equation of the normal. In part B, we have to find the coordinates of the stationary point. So the stationary point basically means that the dy dx will be 0. We already have the expression for dy dx, which is 3 upon square root of 3x minus 4 minus 1. So we'll write 3 upon 3x plus 4 minus 1 equals to 0, as the dy dx equals to 0. Simplifying this, we'll get 3 upon square root of 3x plus 4 equals to 1. Cross multiplying, this will be 3 is equals to square root of 3x plus 4. Now to find the value of x, we'll whole square both the sides. So this will become 9 equals to 3x plus 4. Simplifying this, 3x will be equals to 5 and x will be equals to 5 upon 3. Now to find the value of y, the y coordinate, will substitute this x coordinate in the equation. So the original equation was y equals to 2 square root of 3x plus 4 minus x. 3x plus 4 minus x. Substituting x equals to 5 upon 3, we'll get 2 into 3 bracket 5 upon 3 plus 4 minus 5 upon 3. So this will cancel out. 5 plus 4 is 9 and square root of 9 is 3. So this will become 2 times 3 minus 5 upon 3. Simplifying this, we'll get y equals to 18 minus 5, which is 13 upon 3. So the coordinates of the stationary point will be 5 upon 3, comma 13 upon 3. In part C, we have to determine the nature of the stationary point. So for the nature of a stationary point, first we'll have to find the double derivative. So we already have dy dx as 3 upon square root of, so dy dx is 3 upon square root of 3x plus 4 minus 1. We can write this as 3 into 3x plus 4 to the power minus 1 upon 2 minus 1. Now differentiating this again, we'll get d square y upon dx square is equals to minus 1 upon 2 into 3, which is minus 3 upon 2 into 3x plus 4 to the power. So 1 upon 2 minus 1 will become minus 3 upon 2. And this will multiply by the derivative of 3x plus 4, which is 3. So the final answer for the double derivative will be 3 minus 3 into 3, which is minus 9 upon 2 into 3x plus 4 to the power minus 3 upon 2. Now substituting the x coordinate at the stationary point, which was equals to 4. So the x coordinate was 5 upon 3. Substituting minus 9 upon 2 into 3 into 5 upon 3 plus 4 to the power minus 3 upon 2. We'll get a negative answer, as the minus 9 upon 2 will, and the bracket will have a positive answer, and minus 9 upon 2 is outside the bracket, which means as this will be less than 0, the nature will be a maximum point. In part D, we have to find the exact area of the region bounded by the curve, the x-axis, and the lines x equals to 0 and x equals to 4. Now the equation of the line was given as y equals to 2 square root of 3x plus 4. So this was 2 square root of 3x plus 4 minus x. To find the area bounded by the x-axis and the lines x equals to 0 and x equals to 4, we'll first integrate this equation and put in the limits 4 and 0. So the equation was 2 into 3x plus 4 to the power 1 upon 2 minus x. Integrating this, we'll get, so when we integrate, we increase the power by 1. So 1 upon 2 plus 1 will become 3 upon 2. So this will become 3 upon 2. And we'll divide by the new power, which is 3 upon 2, and multiply it by the derivative of 3x plus 4. So this will multiply by 3 minus the derivative of x, which will be x, the integral of x, which will be x squared upon 2. So the 2 will go in the numerator and become a 4 upon, and this will become a 9 into 3x plus 4 to the power 3 upon 2 minus x squared upon 2. Now substituting the limits, which were 4 and 0. So when we substitute 4 over here, we'll get 4 upon 9 into 3 into 4 is 12. So first, using x equals to 4, we'll get 12 plus 4, which is 16 to the power 3 upon 2 minus 4 squared upon 2. So 4 squared will become 16 upon 2. And then we'll subtract the lower limit, which is 0. So substituting x equals to 0, we'll get 3 times 0, which is 0. So this will be 4 to the power 3 upon 2 minus 0 upon 2, which will be a 0. 16 to the power 3 upon 2. So this will be 4 square root of 16, 4, and 4 cube is 64. So this will be 4 into 64 upon 9 minus 16 upon 2. And this will become minus, so square root of 4 is 2 and 2 cube is 8. So that will be 8 times 4, which is 32 upon 9. Substituting these values in the calculator, the final answer for the area will be 16 holes 8 upon 9.